Welcome to Excel and Finance video number 26. Hey, if you want to download this workbook for Chapter 5 or the PDF file for Chapter 5, click on the link below the video and then go to the Finance section, scroll way down. Hey, Chapter 5, we got to talk about multiple cash flows. So here's what we did last chapter. So last chapter, we talked about one lump sum. That means we had a present value. We put $1,000 in the bank, and we go forward through time, estimating what our future value would be. Doing it from the present value and calculating the actual calculated amount as our future value, that means we're adding the interest in. Here is our math formula we used. We plugged in our numbers, and boom, we got our answer. Now, the reverse is oftentimes important. Again, we're talking Chapter 4, last chapter, one lump sum. We know we need this amount in the future. So we need to estimate what we should put in the bank today. This is going backwards. We know the future value amount. We want to calculate this. So you think of it as we're, in essence, taking out all of the interest. Here was our formula. We plugged in our numbers, and boom, we got 1,000. What's nice about an example like this, right, is we can see either direction, we get the same numbers. Now, we're doing math, but most of the time we're doing Excel. So same calculation. We're going from present value of 1,000. We need to estimate this. We're solving for this. We're adding all the interest in. Here is our FV function, our variables in Excel. Here's the math ones we use just to relate what arguments in Excel and the math ones we use. Plug in our numbers, and we get this. Now, when you're using Excel, Excel knows cash flows. The math formulas don't know cash flows. So here, when we're doing future value as our starting point, we need this amount in the future, given our annual rate, our number of periods, our years. This is what we want in the future. How much do we have to put in today? Taking out all the interest. Here's our PV function, our math symbols, and boom. Notice when we do this in Excel, present value function throws out a minus number because it knows it's coming out of our wallet into the bank. Let's go over to Excel and do these two review examples. All right, first, we always got to calculate our period rate, annual rate divided by number of compounding periods. So I'm going to take my 10% divided by my 2. Total number of periods, always, hey, how many times we get to compound per year times the number of years. And finally, we get to do our FV function. Now notice there it says rate. Don't get confused. It doesn't mean annual rate. It always means period rate. If there's only one compounding period per year, then the annual rate is the same as the period rate. But for us, there's our period rate, comma, NPER. That means number of periods. Total, that one. PMT, we're going to see how to use that in our in this chapter. So we type a comma because we don't have a regular payment here. Present value, it is negative. I hit enter. So because this is negative, this pops out as positive. We would put it in the bank, and we get to withdraw it. Now I'm going to check by doing my math formula there, and I'm going to put a just 1,000. That's the present value times, in parentheses, 1 plus our period rate. Shift 6 to get that caret, total number of periods. Now this is going to pop out as negative because there's a negative because our math formula doesn't understand the cash flow in this particular example. All right. Similarly, we have the future value, and we want to calculate the present value. Still got to calculate that period rate. Whoops. Now watch this. I'm going to point to the edge and drag up. Total number of periods, I'm going to say 2 times 4. And finally, our PV. There's our rate. There's our NPER. Comma, get to our future value. That is a positive, so PV will spit out a negative. To do our math formula, remember, it is the future value amount divided by our factor. So I'm going to divide by, and then 1 plus our period rate. And in Excel, we get to do this a little bit different than math. because we're going to do caret and this. Now, usually we have to put this all in parentheses in math or under a big division bar. But because the order of operations, exponents are calculated before division, this will calculate correctly. 1,000. And math formulas do not see the cash flow as the PV, the FV, and in this chapter, we'll get to see the PMT function. We saw NPR function and some other function, and the rate function, for example, last chapter. Those functions, finance, in Excel, they understand cash flows. All right, now I'm going to go back over to the PDF. Now we're going to switch to this chapter. So we did one lump sum. Now we need to talk about what is the value of multiple cash flows. And we have all sorts of different examples in this chapter, chapter 5. Let's just look at our first example. We have our assumptions here. Annual periods, annual rate, number of compounding periods per year, period rate, years, total number of periods. But look at this, times 0. That means the day we put the stuff in the bank. This is like a saving plan. So we put a savings plan, $1,000 in year 4, or time period 4, because this is not really years. This is going to be a half year, right? We put it in 2,000. Then period 6, time 6, we put in 6,000. And so our question is, in time 10, what is the bank account worth? Now, these are unequal dollar amounts. And however, the period between each, when we have 1, 2, 3, 4, even though we're only putting it in the 4th and the 6th, there's 2 between here and 4 between here. The compounding is done in regular intervals, which means every half year. No problem. We need to calculate what the bank account is worth. Now, we can actually do this from what we learned last chapter. Let's go ahead and look at a picture. Sometimes a picture tells 1,000 words. Times 0, we're going to put $1,000 in. Time 4, which is half year. So this is 1 year, 2 years, second year. Each one of these is a half year. We put in 2,000. Then here, time period 6, which is actually year 3, sorry. Present value, we put in 6,000. And our goal is, what is the total, right? So we can already see the total here. We're solving for this. Multiple cash flows into our investment savings account, and we want to know the future value. Well, we can just do the individual calculations. Not a big deal, and especially when it comes to Excel. This is an example where Excel just rules over doing it by hand. There's our formula. We just plug it in and solve for it. So there's for that first cash in. That's the amount that'll be worth. Now, when you get to the next period, it gets a little bit tricky, only because we have to figure out the exponent. We're going this direction, period 4. But if we're putting 2,000 in right here into the bank account, there's actually this many left for it to earn interest, compound in each period. So we take our 10 minus our 4, and that gives us a 6. Only 6 periods left. But again, it's the same as here. You got to do that individual calculation and bring it forward, adding all the interest in. So we started with 2,000 at this time period, and at the end, it's worth that. Similarly, time 6, we plop it into our account, do our calculations. 10 minus 6, that means 4 periods left. We get our future value amount. We add them all together, and boom. Now remember, multiple cash flows, we're adding. So let's go over to Excel. Go to our next example. I'm going to go to number 3. Period rate. We should be fluent with this by now. Total number of periods, 5 times 2. And now, future value. Well, that's where we're going to calculate our final answer. We have to come down here and build a little template. Now, we're going to do in this chapter a bunch of examples. This first one is individual present value amounts in. And we need to calculate the individual future value amount. Right? So I built the table this way, times 0, just so I know going forward. But then I did the reverse. I just added another column. Hey, that's how many periods are left. So I just did the reverse, right? That way I don't have to do that 10 minus whatever. All right, equals FV. And what's so exciting is we're going to have to remember the difference between relative and absolute cell references, because I don't want to type in 10 or 11 different formulas here. I want to do it one time and copy it down. All right, rate. Well, the rate is this period rate. Now, if I copy this down right now, this dancing ants would move down each time I copied the formula down. So I need to lock it. I'm going to use the F4 key. Comma, NPER. Well, we were clever in the way we set up our template, right? Even though time's going this way, this is the number of periods remaining. So that's a relative cell reference, 1, 2 to my left. Comma, the PMT, not yet. We'll see that in a couple videos. Present value, that's it. And we're going to put our cash flows right in the cells, minus 1,000. The type, we don't need that until we do our annuities a couple videos ahead. So I simply close parentheses, Control Enter, and double click and send it down. Now, when you learn this, you definitely want to understand this formula and how you have to do this by hand. But after you do it a couple times and you're out there working in the real world, you want to be able to do something as quick as that. No problem. Now we just come up here. I'm going to do equals SUM. Now we can just add all of these cash flows. And there it is, $11,602.12. So this is a great first example because all of us can easily imagine putting these amounts in over time. Now, I have these zeros here. You can either put the zeros in or not. It works just fine if there's nothing there. In our next example 4, we'll have nothing there. Now, I'm going to check this. I'm going to do my math formula. Again, it's helpful as you're learning to check the math. But there's another reason, too. I always like to, when I'm doing lots of calculations and they really matter and I can't get them wrong, I like to have 2 ways to calculate everything. That way I can kind of check myself. All right, the present value amount. Remember, future value is present value times, and then in parentheses 1 plus. I got my period rate, and that's going to be locked. Hit the F4 key. Close parentheses, Shift 6 for that caret, and there's the number of periods left. Notice the reason why this can work all the way down is because that amount right there, when it gets down to the 0, right, it's 0 times all this stuff is just 0. So even though we have a 9 there, it won't matter. Control Enter. And I'm going to copy it down. Now, again, this math formula, I'm using it to check. It doesn't understand the cash flows. So there you go. But now let's add this up. I'm going to use the keyboard shortcut Alt equals. Alt equals. All I did is sum. Now, if you don't like the way that looks, and I don't particularly like that way, I'm going to come right here. And I'm just going to start right here. And put a minus sign. Just say, give me the opposite of that. And that way it'll be 1,000. Control Enter, double click and send it down. And that way we can get the same answer. All right, now that's future value. Multiple cash flows. Present value, present value, present value, all the future value. Multiple cash flows, one total at the end. Now let's go back to our PDFs. This is going this direction, adding all the interest in. Now, here's the one where people tend to, when they're learning finance, think it's a little tricky. We're going to go backwards. And here's the problem at hand. We want to withdraw these cash flows in the future. So we would like, in time 4, we have some expenditure we need to plan for, so we're going to have 1,000. Time 6, we have 2,000. And time 10. This isn't the same exact parallel example as that last one. But here are these future amounts. And we want to know, how much do we have to put in the bank today so that we're allowed to take these future cash flows out of the bank? These are positive. Obviously, when we calculate our present value with our Excel function, it's going to be a negative amount because we're going to put this amount in the bank. And then in the future, we'll have these amounts. So here it is. Finally, I look down here, but it's time 0. How much do we put in the bank, right? Here's our same variables over here. So here's the picture. You got to think of this as taking the interest out. Here's the one lump sum amount at time period 10. If I need $6,000, given that I have an annual rate of 10% and compounded twice a year, how much do I need to put in the bank? Well, I just use my formula, right? I calculate this taking all the interest out, and that's the amount. So if I put 3,683.48 cents in 10 years or 10 periods later, 10 half years later, I get 6,000 bucks. I do the same for here. Take all the interest out. This 1,000, take all the interest out. We add them all together, and boom, that is our present value. So we need to know how much to put in the bank to get these future cash flows. All right, let's go over to Excel. We were on sheet 3. Now let's click on sheet 4. All right, now we have our future value amounts. These are the expenditures we are expected. We need some funds to cover in the future. So our question is, how much, what is the present value of these future positive cash flows? How much do we have to put in the bank, one lump sum, to get these future positive cash flow amounts? Now, this template's different than the one where we had present values and we calculated future value, right? So here, we wanted to figure out, these were the amounts we were putting in the bank, and we wanted to calculate the future value. Notice when we got to time 4, it is true that fourth period we put this amount in, but we need to calculate the number of periods going forward. So that's why we did 10 to 0 here, 0 to 4, because at this period here, this is the period we need the cash flow, but we're going backwards. We're, in essence, taking that amount and taking all the interest out. Now, this is called discounting. We're discounting future cash flows, and that's why this rate is often called a discount rate. Could be annual interest rate, APR, discount rate. But when you're doing present value calculations, it's common to say the discount rate. All right, let's go ahead and make our calculations. First, what is the period rate? And the total number of periods. All right, now present value. Well, we're going to have to go, we have a little template here. We have to calculate our present value of each individual amount and then add them all up. Now, we could just do it here and here and here and then add them up, right? But I want to build my template so that any amount that I put in here, it'll automatically calculate it. One further point, we could just start here, but you actually could have flows at time 0, right? It probably wouldn't make sense in terms of doing this present value, because at that moment you have it. Future value, it makes more sense. But I'm going to start right here. Present value. And actually, in present value calculations, you do have amounts at time 0, as we'll see later on. But our idea is we create the formula here, copy it down. Now rate, we know this is period rate. So I click there, and I'm going to hit the F4 key to lock it. Comma, total number of periods, boom, that's going to be 1, 2 cells to my left, a relative cell reference. So as we copy it down, it always changes. Comma, and then payment, don't need that until a couple videos ahead. It's the future value amount. And these are all going to be positive. By the way, these could be whatever sign you want. And in our couple examples ahead, we'll have an example of when you have positive and negative cash flows in the future. Now, there's our calculation. Control Enter. And I'm going to copy it down. So these are present value, and rightly they are negative. So I come up here, equals SUM, and then highlight this column right here. And there's our amount. We put this amount in the bank, given these details here. And sure enough, we can withdraw this amount, and this amount at those particular periods. Now I'm going to check it over here with my math formula. I'm going to take the future value amount and divide it. Open parentheses 1 plus the period rate, caret, and then this period right here. By the way, what's anything raised to the 0? It is 1. Now, I better lock this right here. I put my cursor there and hit the F4 key. Now, something unusual about Excel is that usually in a math formula we have to put parentheses around it or have a big fat fraction bar above it. But because the order of operations, exponents get calculated before division, it'll work just fine. Control Enter, and then I'm going to drag it down. I'm going to come here, Alt equals, just because I'm below it, and it got it right. I'm going to hit Enter. Now, just as when we did our future value amount, if you want these to match the cash flows here exactly, like the awesome built-in functions, I'm going to put a minus sign in front of that future value. I'm sorry, this is present value calculation. These are the future values. These are the present values. All right. All right, so we saw a brief review of what we did last chapter with future value and present value as a lump sum. And then we saw our first example of multiple cash flows for future value and present value. When we come back in our next example, we'll have a few more examples. And in these examples, 3, 4, 5, and 5.5, all the cash flows are different amounts each period. Later in this chapter, we'll see there's a much easier way to do it if all the amounts are exactly the same, like for a loan payment. All right, we'll see you next video.